Okay, so in this tutorial, we're going to talk about adding Earth intelligence layers in Nebulum. Now, over in the left sidebar here, you'll see 2 layer slots available to activate. So let's click on layer 1 to bring up this satellite selection pop-up, which will offer us a range of different satellite intelligence layers. So all of these options here are built to do different things. Now, some of these options are built for monitoring vegetation health, like this option right here. Others detect moisture, like this option right here. And some of these layers, like this thermal layer or these radar options down here, can actually pierce through cloud cover entirely, meaning that you can capture ground truth without having to worry about weather. And also, it's really important to remember that if you're ever looking at these options and you're just not sure which one fits what you're trying to do, you can always just ask the AI. So click on this button right here, describe your use case, and our AI will help you figure out the right layer to use. Also, if you ever feel lost on this map, you can always just toggle map labels on by clicking on this little switch right here. Now you'll see things like road names, landmarks, borders, and so on. Okay, so let's jump back over into our Earth intelligence pop-up here. Now, before we activate anything, let's just take a quick look at how these cards are organized. Now, each card starts with a plain English title, high resolution historical archive, which you see right here, vegetation health, which you see here, thermal, radar, and so on. Now, to the left of each title, you'll actually see a small thumbnail showing you a preview of what that layer's imagery will actually look like. And then down below here, you'll also see a short description of what this layer does and what it's most commonly used for. Now, below the title, you'll also find the technical details of each layer. You'll see the data source or the satellite provider. Sentinel-1 and Sentinel-2 are satellites operated by the European Space Agency. NASA MODIS and NASA VIIRS are Earth observing instruments operated by NASA. Landsat is a long-running joint program between NASA and the U.S. Geological Survey, providing continuous satellite imagery of Earth's surface since the 70s. And Esri Wayback is a curated archive of high-quality historical imagery sourced from a wide range of Earth observation providers, including some of the most expensive Earth observation providers out there. Now, Nebulum pulls from all these sources simultaneously, which means with a single click, you're tapping into hardware that governments and research institutions have spent billions of dollars putting into orbit. So to give you some visual context here, here is the Landsat satellite that you can connect to within Nebulum. And here is a short animation of a Sentinel-2 satellite when it was first deployed to space. So every time you log into Nebulum, this is the hardware that you're connecting to. Okay, so back in our pop-up here, you'll also see how each satellite views the world. So true color imagery, like this Sentinel-2 option here, closely resembles what the human eye sees. But satellites can observe far beyond the visible spectrum. Now, depending on the sensor, they can capture near infrared, shortwave infrared, thermal infrared radiation, radar backscatter, and more. Now, each of these instruments can reveal different information about the same area on Earth, from vegetation health and moisture levels to surface temperature, land cover, and even things like structural characteristics. Now, after that, you'll see resolution right here. Now, this number refers to the size of each pixel on the ground, so lower numbers mean sharper imagery. At the highest end, this high-res historical imagery option here can be sub-meter resolution in many locations. Sentinel-2 provides 10-meter imagery, Landsat 30-meter imagery, while MODIS and VIIRS range from roughly 250 meters to 1 kilometer per pixel. As resolution decreases, fine detail is lost, but coverage also tends to increase, allowing satellites like MODIS and VIIRS to monitor the entire planet every day. And it's important to note that resolution isn't everything. NASA's MODIS and VIIRS instruments, as I just pointed out, have relatively low spatial resolution, but that's because they were designed for a very different purpose. They have a very distinct mission profile. So rather than capturing fine detail, these satellites were built to survey the planet every single day at a global scale. Now, as you can see here, the resolution is low, but the revisit rate is exceptionally high daily, and that's what makes them invaluable for tracking things like wildfire smoke, flood extent, drought conditions, storms, and large-scale deforestation. Now, you won't be reading license plates with this imagery, but you will be watching the planet breathe. Now, for this kind of work, daily coverage obviously matters way more than pixel sharpness, which brings me to the next number here, which is the revisit rate. Now, this tells you how frequently a satellite passes over the same location on Earth. MODIS and VIIRS provide daily coverage. Sentinel-2 revisits approximately every 5 days. Sentinel-1 returns every 6 days. Landsat revisits every 16 days. And then here you'll see this option for HLS, which stands for Harmonized Landsat Sentinel, which goes a step further by blending observations from Landsat and Sentinel-2 into a single dataset. Now, by combining both missions, HLS can achieve a revisit rate of roughly 2 to 3 days, depending on location and cloud cover. As a general rule, the sharper the image, the less frequently it arrives. The faster the revisit rate, the broader and coarser the view. So yeah, knowing what you're trying to answer will help you figure out which trade-off matters more for your specific work. Okay, so let's see how different layer choices play out on the map here. So for example, with our high-res Earth Archive layer selected, let's zoom in to this airport in Sudan here. Now I've included the coordinates below this video for this location. The imagery shown here is from March 15th, 2023. In mid-April 2023, fighting erupted in this area, and this airport sustained visible damage. Yet when I examine imagery from early May 2003, that damage still isn't reflected in the map yet. It's not until May 9th, 2024, more than a year later, that the updated imagery appears and the damage becomes visible in these tiles right here. Now, this is an important limitation to understand. The high-resolution historical archive prioritizes image quality and visual consistency over recency. While it provides an excellent overview of an area, it may not always reflect the most current conditions on the ground. If verifying ground truth on a specific date is critical to your work, one of the timestamp satellite layers will usually be a better choice. But if resolution is your priority and an exact acquisition date is less important, the high-resolution historical archive offers some of the richest and most detailed imagery available. In practice, you'll often use both together. For example, I might use the high-resolution historical archive as layer 1 to provide some context, and then I'll apply Sentinel-2, this true color option right here, as my second layer to provide current ground truth. The Sentinel-2 imagery may be slightly lower resolution, but it gives you much more confidence about when the observation was made. For example, now I can see the destruction on the map in near real time. Okay, so back into our pop-up here. Now at the bottom of each card, you'll see two final pieces of information. First, the estimated date of the satellite's last pass over the area, so you'll have a sense of how fresh this data is. And then second, whether this layer consumes credits or is free to use. So free credits can be activated as often as you like without touching your balance. Premium layers draw from your Nebulum credits each time a new map tile is loaded. Let me quickly show you what I mean by this. So let's activate this high-res archive option here. Now I'm at this island in the Canary Islands, and notice that as I move around and load more tiles that my credits don't go down. I'll load the same layer as my second layer here, and then I'll pick a future date so we can see how a volcano on this island devastated the southern part of the island. Now don't worry, because even though these images are pretty horrific, as you can see here, this volcano swallowed this entire town. Luckily, this island was evacuated before this eruption. Again, notice as I move around the map, all of these tiles load. Also, notice that my consumed credits remain at 0. The same will happen if I activate any other of these free layers within this pop-up here, for example, layers like MODIS or VIIRS. Now what you see on the screen right now is an example of how VIIRS looks. MODIS looks very similar. Again, notice the lower resolution, so I'm not seeing any fine details here, but I am able to do things like see these forest fires in Portugal and Spain from 2025. Or notice here that we can look back at the forest fires of California from 2020. Here is how it looks with VIIRS selected to the left and VIIRS infrared activated on layer 2 to the right. Notice how if I zoom in, the infrared layer can actually cut through the smoke and we can see the actual fires blazing right here. Using this layer, we can also do things like view the formation of hurricanes. We can also see major flooding events like this flooding event in Pakistan. And remember, these satellites have daily coverage, so we can also monitor these events each day. Again, you can do an unlimited amount of searching with any of these non-credit-based satellite systems. But now let's deactivate these layers by clicking on Remove Layer here, and then we'll add a True Color Sentinel layer. Now before clicking on this layer, notice that we can see here that it will consume credits, so let's activate this layer now. So I'm zoomed into a mine here. So let's imagine that I wanted to know if this mine was expanding and I wanted to know this in near real time. Now I'm zoomed into my base map here, and this is how the mine area looks at the most recent date from this base map. But as you can see here, when I activate the Sentinel layer, we can definitely see new human activity and growth here. Now I'm pretty zoomed in here, so I didn't need to load too many premium tiles to populate my screen with this intel. But as you can see, even just activating this premium layer consumes some credits. We can see credit usage over in the left sidebar right here. Now, if I loaded more tiles by zooming out or panning around, even more credits would be consumed because more tiles are loading. So in order to keep your credit count down, what I suggest you do is to try to establish your desired zoom before activating a premium layer and keep panning around and zooming out to a minimum. Also, always remember to deactivate the layer once you're done using it. Also, we'll talk about snaps in an upcoming tutorial, but if you want to save a record of this view after consuming credits so you don't always have to come back to what you've already seen, you can do that by first ensuring that you're on an area of interest page and not the explore page. Now, on a monitored area of interest page, you can create a new view, and then you can populate that view with snaps from different points in time. Now, this allows you to keep a well-organized record of the satellite data that is valuable to you for your use case without having to rerun premium layers and use more credits each time you want to unearth data or revisit data. So for example, I could store true color images of this mine in one view. I could store radar snaps that see through clouds in another view. I could even do things like focus in on this specific area over here and save infrastructure analysis or vegetation snaps from different points in time. This allows me to build up a historical record of the area using different satellites, sensors, and imaging techniques. So I might save true color imagery in one view, radar imagery in another, and vegetation or infrastructure analysis in a third. Each snap captures exactly what I was seeing at that moment in time. Now, once a snap has been created, it's stored as a JPEG image. That means that you can return to that view anytime without having to rerun the satellite layer or consume additional credits. So in practice, you'll often use credits to discover, analyze, and capture valuable imagery, and then after that, you can revisit, compare, study, share, or present those findings as often as you like without having to spend more credits. Now, you can view your snaps in a beautiful calendar format by clicking on Timeline and then selecting this calendar view from right here. Notice how all of your snaps will be organized chronologically, making it easy to browse through your historical imagery. Now, clicking on any snap opens a preview, and you can use the full screen button here to examine this image in greater detail. Or back on the main page, we could click on Timeline again, and then this time we can select Slideshow to launch a dedicated viewer that lets you move through your snaps one by one. Now, these tools do a lot more than just help reduce credit usage. They help you build a visual story around the area that you're monitoring. So whether you're tracking mine expansion, infrastructure development, flooding, vegetation change, a political conflict, or wildfire recovery, the timeline and slideshow views make it easy to spot patterns, detect change, and understand how a location evolves over time. Now, instead of looking at individual images in isolation, you're now able to see how the narrative unfolds across months or even years of satellite observations. And remember, with regards to credits, you can always view your credit balance over to the left sidebar here. And if you ever need to top up credits, you can always easily do that by visiting your account page by clicking on this icon right here. Okay, so let's remove this premium layer now to stop consuming credits by clicking on this remove button right here. Okay, so that's credits in a nutshell. Let's get back into our Earth intelligence layers here. Okay, so lastly, let's just take a quick look at the date picker. Now, different satellite providers publish different types of metadata. So for example, our high resolution base map does not publish cloud information because the imagery is curated and mosaicked to minimize cloud contamination. Similarly, MODIS and VIIRS do not provide scene level cloud cover values used by the calendar, so dates from these sources will appear with gray dots. However, when using satellites such as Sentinel-2, which does publish cloud cover information, you'll see little color-coded dots in the calendar right here. Now notice that after selecting a Sentinel layer, the system may take a few moments to populate the calendar, and that's because it's querying the available imagery for your selected region and retrieving cloud cover information for each available date. Now once the search is complete, you'll see little color-coded dots after selecting the date picker. So green dots indicate low cloud cover, yellow and orange dots indicate moderate cloud cover, and red dots indicate high cloud cover. Now, while cloud cover isn't always a perfect indicator of image quality, it's often a useful starting point when searching for clear observations from an area. In most cases, you'll want to begin with the green dates and then work around from there. So that's Earth intelligence layers within Nebulum in a nutshell. So hopefully that gives you a solid foundation for getting started within the platform. Now, there's still much more to cover in the Academy, but with what you've just learned here, you should be ready to start building areas of interest, exploring historical imagery, and uncovering insights from satellite data. So thanks for joining me today, and I'll see you over in the next tutorial.